Hi friends, today we are evaluating trig functions. We've done this before in degrees, and today we're going to take it into radians, right? So just a reminder on what trig functions are. Trig functions, remember, are sine, cosine, and tangent, and they have their reciprocal functions, right? The flipped versions of them. So if we are thinking about sine, we're thinking about y over r. We're thinking about cosine, we're thinking about x over r. We're thinking about tangent, we're thinking y over x, like that, right? Our reciprocal versions, reciprocal for sine is cosecant. Reciprocal for cosine is secant, and reciprocal for tangent is cotangent. So that would be like the flipped version. So for cosecant, r over y. For secant, r over x. For cotangent, x over y. Okay. So we'll be using these today in order to evaluate the trig function and graph it in its appropriate quadrant. And we're going to label the reference angle. We're going to get some more practice with that reference angle. Okay. So let's zoom into number one, cosine pi over 3. Remember pi over 3, like pi is just like 180 degrees. So 180 over 3, that'd be like 60 degrees. Right? So in my head, I'm thinking, okay, this is 60 degrees. I'm going to go ahead and plot it right here. Right? So that's going to make this 60. I'm going to go ahead and drop this triangle down. Right? So I have 60 degrees. My reference angle is just the closest way to get to the x-axis. And so I went this way for my angle, but my reference angle is just going to collapse right back here. So my reference angle is 60 degrees as well. All right, knowing that it is 60 degrees, and we know that this is 90 because we just drew it straight down. So we know this must be 30. This is a 30, 60, 90 triangle. So I know short side is 1, hypotenuse is 2, side across from 60 is square root of 3. It's in the positive, so I don't have to worry about negatives for this one. And I want cosine. Cosine is x over r, right? So x in this case is 1, and r in this case, the radius is 2. So 1/2 would be my answer here. Let's double check. We're evaluating each trigonometric function. We did that. That's this part here. We graphed it in its appropriate quadrant. That's this part here. And labeling the reference angle, we have our reference angle here, which would be this position here. Okay. Let's go ahead and try the second one for sine. So this one says sine 2 pi over 3, right? So pi over 3, that is, remember, 60 degrees. And we have 2 of them this time. So this is 120 degrees. Let me go ahead and draw it over here. 120 degrees. That is the angle that we are that we have here, right? We could also call it 2 pi over 3. Right, if we wanted to talk in radians. So that is basically like we did 90 and then 30 more. So the reference angle is straight down to the x-axis. That reference angle would be 60, right? It's like basically how much more do we have to go to get to that 180 here? So I'm going to drop that line straight down. And I have my reference angle. I'll go ahead and mark it here, 60 degrees. So I have 60, I know 30, 60, 90 again. Short side is 1, hypotenuse is 2, square root of 3. Since this is on the negative x, I'm going to make this negative 1. And this is positive because it's on the positive y here. Sine, remember, is sine, y over r. Y over r, so I have square root of 3 over r, which is 2. So this would be the equivalent of sine of this angle. This is my answer here. Drawn my triangle, and I have my reference angle. Okay. Go ahead and try this next one, number 3. Try it on your own. Pause the video, and then come back for the notes. All right, so we have our tangent of 3 pi over 4. Remember, pi over 4 is 45 degrees. Multiply that times 3 because we have 3 pi over 4. That'd be 135. So that is like this whole distance over here, right? It's the measurement of this angle. So since it's 135 over here, that means the leftover, the reference angle would be 45 degrees. So I'm going to label my reference angle is 45 degrees. I know that that makes this a 45, 45, 90 triangle. So I'm going to have 1, 1, square root of 2. 1, 1, square root of 2 as my radius, right? I know that this is negative, just like we had before. So we have negative 1, 1, and square root of 2. Tangent is y over x. Tangent is y over x. So I'm thinking here, okay, I have y is 1, x is negative 1. So when we simplify that, we're going to get negative 1. So the tangent of 3 pi over 4 is negative 1. Awesome. So far, this has been very similar to what we've done in the past, right? Draw the triangle, fill in the sides, find the ratio, and fill in what that is there, right? We added in the reference angle on Tuesday, but so far, pretty similar using gradients. We're also going to look at what happens when a triangle doesn't exist, right? Or when we have something more interesting along our axes, right? So for this one, we're going to be dealing with cosecant. Cosecant is the opposite of sine, right? The reciprocal of sine. Sine is y over r, so we're going to turn that into r over y, right? So cosecant is r over y. And then this here is pi over 2. If you're thinking pi over 2, like 180 over 2, I would have 90 degrees. So this is 90 degrees here. So here, we basically have a line like this. But if you think about it, like when I have a line like this, I draw a line straight down to make a triangle. If I draw my line here, let's say I draw my line in purple, and then I draw a line straight down in red, I have this same line, right? So I just have a line here. So let's think about what this means in terms of like our x, our y, and our r, right? So my x, I have not gone anywhere left or right here, right? I haven't gone anywhere left or right. So my x here is 0, right? I don't have anything for my x, right? My y is going to be 1, right? You can make it whatever you want, essentially. But the idea is whatever your y is, so is your r. We're going to deal with what's called the unit circle here, which just means that our distance here is 1. Our radius is 1. So our y is 1 because we're going up and down, and our radius is 1 because the distance from the center to the top is 1, right? Distance is 1 there. So my x is 0, my y is 1, and my r is 1, right? So on this axis here, I have my r is going to be positive 1. My y is positive 1. It would be negative 1 if it was down here on the bottom, positive 1. So my cosecant of pi over 2 would be 1 over 1, which is just 1 as an answer. Okay, so cosecant of pi over 2 equals 1. So this is what we're going to do if we have any point that is on an axis. So let's go ahead and talk about another point that's on an axis. So for tangent of negative 3 pi over 2, right, negative 3 pi over 2, I know that pi over 2 is 90, and this would be 3, right? This would be 3 of the 90s. So pi over 2 is 90 times negative 3 would be negative 270 degrees. Remember that it goes in the backwards position, right? It goes in the backwards direction when it's negative. So instead of going this way, like positive, we're going to go the other direction. So I'm going to go 90, 180, and whoops, and here we go, 90, 180, and all the way around to 270. So that's negative 270 is this angle over here, from here all the way to here. So I end up here again, right? Let's think back. What is my x? I have not gone left or right. So my x is still 0. What is my y? I'm still at positive 1 because I've gone up 1, right? And what is my radius? What's my distance from 0? My distance from 0 from here, or from the center to here, is also 1. Right? So x is 0, y is 1, and r is 1. Remember, tangent is y over x. My y is 1, and my x is 0. My x is 0. I haven't moved anything. Right, so I'm thinking, okay, 1 divided by 0, anything put into 0 groups, I can't do it, right? If I have 5 things and I try to put them in 0 groups, it's not going to work. I'm always going to have something. So I cannot divide by 0. This is called undefined. So the only situation where you would get undefined is when you're dividing by 0. We see that when we have our x here. Let's do one more that's like this. We'll jump in here. We have sine 6 pi. If you want to try it on your own, you're welcome to, but we'll jump in. So sine 6 pi, remember pi is 180, and we're multiplying times 6. If I do 6 times 180 on my calculator, I get 1,080, like that. I think it's also easier to just say, okay, I know that pi is, that's 1 pi. Here's 2 pi, here's 3 pi, here's 4 pi, here's 5 pi, here's 6 pi, right? So I ended up right here. I ended up back here where I started, essentially, right? I just went around and around and around with my angle. So 6 pi, remember 2 pi is a whole rotation, so that'd be 3 rotations around. So I went round and round and round, and now I'm thinking, okay, what is x, what is y, and what is r? So x in this case is positive 1, because we are moving in that direction, positive 1. Y, my up and down, I haven't gone up or down any, so my y in this case is 0. Right? I haven't gone up or down any, I just have a flat line. And then my radius, remember, would be this, the distance from the center to the outside, which we've said is 1. So my radius would also be 1. So sine is y over r. So in this case, my y is 0, and my radius is 1. Right? Different from this one, we are not allowed to divide by 0, but we can divide by 1. If I have 0 things and I put them in one group, I just have 0 things in that one group. Right? So this is just equal to 0. So something to be really careful of, 1 divided by 0 is undefined, but 0 divided by 1 is just 0. So 0 would be our answer for sine 6 pi. All right. This is the end of our official notes. We did some with triangles, and then we learned about some with axes as well, like when they're on the axis. If you want to see some more examples, I'm going to continue in this video, but if you want to be done, it's the end of our notes for today. Cool. All right, so let's look at secant 7 pi over 6. Pi over 6, pi over 6 is 30 degrees, times 7 would be 210 degrees. So I know that I am over here in this quadrant here. Draw a dark line there, over there. I also know, like, I went like 1, 2, 3, 4, 5, 6, and then now I'm at 7 of 6, right? I've gone all the way around here. So this is my 210 degrees. Right? When I draw my triangle straight up, my reference angle is going to be 30, right? That's what I have. This distance right here is 30, which makes this one 60, and right angle. So I have 30, short side is 1, long side, hypotenuse is 2. We have square root of 3 here. So think about your positives and negatives. So I have a negative here, a negative 1, because I'm in the negative x and the negative y. Secant is the reciprocal of cosine. Cosine is x over r. So we would have r over x is what we're looking for here. My r is 2, and x is negative square root of 3. Right? Negative square root of 3. We don't want to leave the square root in the bottom. We can push the negative in front. So I have -2 over square root of 3. I'm going to multiply by square root of 3 on top and bottom. So I get -2 square root 3 over 3. That's my answer. So we have a more complicated problem here. We have secant, cosine, flip it over. We've got our simplification. Cool. Anytime you want to pause the video, go for it. Pi over 3 is 60 degrees. Right, I have -60, so I'm going to be going in the backwards direction here. So I would have something like this, 60 degrees. I know my short side across from the 30 is 1, long side 2, square root of 3 for the middle. I know this one is positive, but square root of 3 is negative. Cotangent is the reciprocal of tangent. Tangent is y over x. So when we flip this over, we're going to have x over y. Right? So x would be 1. Y would be negative square root 3. So we're going to simplify square root of 3 on top and bottom. I get square root of 3 over 3. Push that negative out in front. This is my answer here. Nice. All right, let's do one last one. This is another one like 5 or 3 through 4 through 6, the axis problems, right? So cotangent of pi. Cotangent of pi. I know pi is 180, so I'm going to be over here. I'm going to be over here. My x then would be -1 since I'm on the negative side. My radius is +1. Radius is always positive because it's the distance. It's absolute value, distance from the center to the outside, no matter what direction you're going. And then my y would be 0 because I'm not moving up and down at all. And so I could really write it like right here, y equals 0. All right, cotangent, as we stated, is the reciprocal of tangent. Tangent's y over x, so we're going to be flipping that over to x over y. So in this case, we have x is -1, y is 0. Anytime we're dividing by 0, we have a problem. We are undefined. So the answer to this one is undefined. If you were to put this in your calculator in radians, it would tell you error undefined. Cool. All right, so we've got 9 examples. Feel free to ask questions, whatever you got, and we'll jump on in. Thanks, y'all.